Hello, I'm Brian, and welcome to this Gray-Ed virtual lesson on Newton's laws of motion. These fundamental laws lie at the heart of classical physics and are essential to understanding the world around us. In today's interactive lesson, we will dive deep into each of the three laws, providing detailed explanations, examples, and practice questions to help you master this important topic in physics. Remember, the process of figuring out the answers is just as important as the answers themselves. Remember to feel free to ask Gray-Ed any question throughout the lesson. Newton's first law, also known as the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and direction unless acted upon by an external force. The key concept here is inertia. The more massive an object, the more inertia it has, and the more force is required to change its state of motion. Let us use this example. If you slide a book across a table, it eventually comes to a stop due to friction. However, if there were no friction, the book would continue to slide at constant speed forever, as there would be no net force acting on it. Why does a soccer ball come to a stop after being kicked on a grass field? Take a moment to think about your answer, and then I will explain the solution. The soccer ball comes to a stop because of the friction between the ball and the grass. The frictional force opposes the motion of the ball, causing it to slow down and eventually stop. This demonstrates Newton's first law, as the ball changes its state of motion due to an external force, friction. Feel free to ask Gray-Ed on any questions you might have at this point. Let us look at Newton's second law. Newton's second law explains the relationship between force, mass, and acceleration. The acceleration of an object depends on two factors, the net force acting on it and its mass. The greater the net force, the greater the acceleration. Conversely, the greater the mass, the lower the acceleration. To calculate the net force, use the formula F equals ma, where F is the net force, m is the mass, and it is the acceleration. A 5 kg object is pushed with a force of 20 N. What is the acceleration of the object? Take a moment to work through the problem, and then I will explain the solution. Using the formula F equals ma, we can rearrange it to find the acceleration. A equals F slash m. Plugging in the values, we get A equals 20 N slash 5 kg, which simplifies to A equals 4m slash s2. So, the acceleration of the object is 4m slash s2. Remember, if you have any questions, feel free to ask Gray-Ed. Let's move on to Newton's third law. Newton's third law states that forces always come in pairs. Whenever an object exerts a force on another object, the second object exerts an equal and opposite force on the first. These action-reaction force pairs act on different objects and do not cancel each other out. Let's picture this example. When you jump off a diving board, you push down on the board with a force, action, and the board pushes back on you with an equal and opposite force, reaction, propelling you into the air. You push a heavy box across the floor with a force of 100 N. What force does the box exert on you, and in which direction? Take a moment to work through the problem, and then I will explain the solution. According to Newton's third law, the box exerts an equal and opposite force on you. This means the force the box exerts on you is also 100 N, but in the opposite direction. Remember, if you have any questions, feel free to ask Gray-Ed. Well, that is it for today's lesson on Newton's laws of motion. From this lesson, you should have a basic understanding of Newton's three laws. Join me next time as we dive deeper into this fascinating topic. For now, go ahead and ask Gray-Ed any questions you have about this lesson and for some practice questions. See you next time.